distance versus displacement. So distance is a scalar that just has magnitude, and displacement is a vector with both magnitude and direction. Distance would be basically the space covered between 2 points with respect to the path taken. So this is like what your odometer would read. It doesn't care where the car has gone, it's just keeping track of the overall mileage. Displacement, however, is simply the change between the 2 points. So that would be a straight line. Graphically speaking, it would be a straight line between A to B. It is a vector because it does have direction. Both are measured in meters. One popular, or not necessarily popular example, but one example I give is, say this is the block that my house is on, and I go walking around. Oh goodness. So maybe the path I take looks something like this. With me both starting and stopping at the same point. But walking my dog, maybe she takes a different route. So she leaves, goes sniff a mailbox, go chase a kid on a bike, I don't know. Walks around, says hi to another dog, sniffs some other stuff, barks at some other things. Normal dog stuff. And then comes back. We could say that my dog covered the greater distance, but the displacement for both of us would be the same since we both started and ended in the same spot. Solving displacement problems is similar to solving your typical vector problems. If we have 3 meters to the right, 2 meters to the left, our resultant displacement would be 1 meter to the right. However, our total distance traveled would be 5 meters. That would be a 1D example. 2-dimensional example, perhaps we have 3 meters at an angle and 1 meter up. We could use component method or graphical to determine the actual resultant velocity there. Or not the resultant velocity, the resultant displacement. And that's the big difference between distance and displacement. One is a scalar, while the other one is a vector.